We have seen what is basic proportionality theorem, also known as the Thales theorem. Do you think the converse of BPT would also be true? The converse of basic proportionality theorem says that if a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side. So if we have a triangle ABC and a line DE such that this DE divides AB and AC in the same ratio, that is, if AD divided by DB is equal to AE divided by EC, then this line DE is parallel to the third side BC. Now, in order to examine if this converse is actually true, let us first perform one activity. Let us take an angle XAY, and from this point A, we are going to make some arcs, equidistant arcs. Let's say we take here and we take arcs of 1 centimeter over here. So we'll make arcs, we call it, let's call it B1, another one B2, B3, B4, and B. If you just see, we have made these arcs at 1 centimeter each. Okay. So we see that AB1 is equal to B1, B2 is equal to B2, B3 is equal to B3, B4 is equal to B4, B. And all of these are equal to 1 centimeter each. Similarly, from this point A, let us make some arcs on AX as well. So let's call this C1, C2, C3, C4, and C. Now, we have placed these arcs at 2 centimeter each. So, AC1 is equal to C1, C2 equal to C2, C3, and so on. And these are equal to 2 centimeter. Now, let us connect B1 to C1 and B to C. Doing that, we actually get a triangle ABC, where this B1 is a point on AB and C1 is a point on AC, and we have connected these 2 points as well. Right? Now, if you just check the ratio of AB1 to B1B, that is, we need this. So we know that we have placed it at 1 centimeter each, right? AB1 is 1 and B1 to B is 1, 2, 3, 4. So the ratio is 1 by 4. Similarly, let us find the ratio of AC1 to C1C. Now we know that this is 2 and this would be 2, 4, 6, 8. So this is 2 by 8, which is again 1 by 4. So we get that AB1 divided by B1B is equal to the ratio of AC1 to C1C. Also, if you just check this angle, let's zoom it a little bit. This is 70 degrees. If you check this angle as well, this is 70 degrees too. So we have these two lines, B1, C1 and BC, and this AY is acting like the transversal here. Also, the corresponding angles are equal. So by converse of corresponding angle theorem, we see that B1, C1 is parallel to BC. So we observe that in this triangle, we just had 2 points on 2 sides, where those 2 points were dividing the 2 sides in equal ratio. And then we also notice that these 2 lines are then parallel. Let us also try and see what happens if we connect B2 to C2. Once again, we are going to check the ratio. AB2, which will be 1, 2. B2 to B will be 1, 2, 3. So this is going to be 2 by 3. AC2 is 2 into 4. And distance between C2 to C is 2, 4, 6. So 4 by 6. 4 by 6 is again 2 by 3. So these ratios are equal to 2 by 3. Once again, if you will check these angles, we'll find them. This is 70 and this is 70 as well. The corresponding angles are equal. That means these lines B2, C2 and BC are parallel. Similarly, now you can connect B3 to C3 And you will realize that this ratio is 3/2. This is 6/4, which is again 3/2. And once again, these lines would be parallel. Similarly, if we connect these two, P4 and C4, the ratio would be 1, 2, 3, 4. 4:1. This is 8:2, which is again 4:1. And once again, the lines would be parallel. If we just check the corresponding angles, we can verify this. So we have just seen an activity which has verified the converse of BPT. Let us also look at its proof, the mathematical proof. The converse theorem, it says that if a line divides two sides of a triangle the same ratio, then that line is parallel to the third side. So let's see what is given to us. A triangle ABC and a line DE such that AD upon DB is equal to AE upon EC. And we need to prove that this DE is parallel to BC. Let us assume that DE is not parallel. Then there has to be a line which will be parallel to BC. Let's make that line to be DE dash. Okay. If DE dash is parallel to BC, then by BPT theorem, we get AD upon DB is equal to AE dash upon E dash C, right? That the Thales theorem would give us this ratio, this proportion, sorry. But we also have this which is given to us. AD upon DB is actually equal to AE upon EC. So through these two, we get that AE upon EC is equal to AE dash upon E dash C. Let's write this in a new page. Now, how about if we add 1 to both the sides? You'll see why we are doing this. Let's add 1 to both the sides and take this LCM. So we'll have EC in the denominator, and in the numerator, we'll have AE plus EC. Similarly, over here, we'll have AE dash plus E dash C divided by E dash C. What is AE plus EC? AE plus EC is nothing but AC. AE dash plus E dash C is also AC. So we get this proportion. Now, the numerator is equal, the ratios are also equal. That means the denominator is also equal, which implies EC is equal to E dash C. Now, since E and E dash, they both lie on AC and divided identically, that means E and E dash have to be the same point. Let's say if EC is 4, then E dash C is also 4. And these are lying on the same line EC. So if this is 4 and this is 4 as well, that means E and E dash will coincide. These two will actually be the same point, which gives us that line DE and DE dash are the same lines. Since DE dash is parallel to BC, we took it to be parallel to BC initially, right? That means DE is also parallel to BC, which contradicts our assumption that DE is not parallel to BC. Hence, the converse of basic proportionality theorem stands true.